Hey everyone and welcome to this project. In this project we will build a real-time chat application using Spring Boot and AWS. Now before you start building this project, you should know already the basics of Spring Boot and AWS. So without further ado, let's start. So let's first start with creating a new project. So go right here, a new project, and we'll pick a Spring project. We will call it chat app. We will use Maven and YAML for the configuration. Click next, and now we will add all of our dependency. The first one will be for Spring Web. So web, we will pick Spring Web. After that, we will add the WebSocket, as we are needing a WebSocket for a chat application. Now we'll add Spring Security. We will add this one, and we'll add also Spring Data JPA. So Spring Data JPA. Flyway migration. So Flyway migration. PostgreSQL driver. H2 in-memory database for testing, and Spring Boot Actuar to see the logs and status of our application. So let's add Spring Boot Actuar. So Actuar, and we need to add validation and Lombok. So validation and also Lombok to cut out all of the boilerplate code. So we have Spring Web, WebSocket, Security, JPA migration, PostgreSQL driver, H2 database for the testing, Spring Boot Actuar for logs and managing our application, validation and Lombok for the annotation and validation for our code. So let's hit create. Great, now let's go to our pom.xml file. We need to add some dependency that we couldn't add in the initialization of the project. So let's find those. Now the H2 database will change the scope from runtime to test, and we will also add some dependencies for JWT. So let's add those. So let's add them real quick. Let's start with the JWT one. So right under all of the dependencies, let's add a new dependency. This one will be for JWT. We need the API implementation and Jackson. We don't need the root, so click create again dependency JWT implementation, and now we only need the Jackson. So dependencies JWT, and we need the Jackson, and we have the JWT. And let's load Maven. Great. Now let's go out to our application YAML configuration file, and let's give all of the needed configuration: src, main, resources, and to application YAML. Great. Now we have the application name. Now let's continue to database, data source. So data source, now the URL will be JDBC, as you familiar, PostgreSQL, local host on port 5432 slash chatdb, and we will shortly create this database. Now the username will be, and now it will be an environment variable, but if you don't have this environment variable, we can use something else. So let me show you. db dash username, but if you don't have it, we put a column and we say it or chat user. The same goes for the password. We can do the similar thing, db password or set password. And finally, the drive class name will be PostgreSQL. So driver class name will be org.postgresql.driver. And this is for our data source. We will shortly create a PostgreSQL file for local production, for local development, and for production we will use RDS, and we will set it up when we will prepare for production. So now let's add the JPA configuration. First one will be hibernate, and DLLota validate. We put it to validate so Flyway will manage the schema and not hibernate. Now we can have also show SQL. If you want to see the SQL, we can turn it into true or false. We don't actually need it for that kind of production. Now per this, we have hibernate in here as well. So hibernate and deallocate and allocate, and for the allocate we will do org.hibernate.deallocate.postgresql deallocate. And lastly, format SQL. So format under SQL URL, we will do it to true, a typo format. So this is for our JPA configuration. Now let's go to our flyweight configuration. So flyweight, let's configure real quick. Enabled, of course, to true, and I build will put this, of course, to true. Location will be for all of our different migration. There will be class path of db slash migration, and the baseline on migrate we will put us to true as well. And for JWT we can also add the configuration. So JWT secret will be an environment variable, which will be JWT secret, very simple, red, or long 256 byte secret. And for expiration, this is in milliseconds, so 86 4, and you will put 5 zeros. This is for a full day. And now for our final configuration, let's add the server. So server port, let's ensure that it will be on port 80. And now for the actual, for our management, so management endpoints web for sure include health and info. Those are the endpoint from the actual, and endpoint for the health show details, and it will be when authorized, so not everyone could see the details. So this is for our development. Now let's copy it, and we need to create one for the test. So right here in test we have Java folder. Let's add also a new file for the YAML file, and we first of all put it in the resources folder. So this, so says slash application test.yaml. Let's do this. Great. Now we need to change a few things. First of all, we will use h2 in memory database, meme test-db, and db-close da will be to -1, and db close on exit will be false. So db close on exit will be false. And now the really configuration that is important was like uppercase. We need to change the mode. Now the mode is determined how the database will behave, so we will put it at PostgreSQL. So it will behave like our PostgreSQL. Now username and password we can leave it, not really important. For the driver class it will be org h2. Now for the Hibernate it will be create drop, so it will recreate it every time. Now we need to change this PostgreSQL to h2, and we will disable flyway. So we will put this to false because we will not use flyway in our test. For JWT we'll have the secret key, but we don't need a port or the management because those are only the test. Great. So now we will set up our CLI, our CD and CI/CD pipelines, which, let me just refresh your memory. CI/CD pipelines, they are used for creating a certain pipelines, so you will have a nice workflow, and we will create those real short. So right here, new file, it will be at github.github.workflows, so workflows/ci-cd.yaml. This is the path that it's look for when we are talking about CI/CD pipeline. So click enter. Yes. Now we'll add all of the jobs in a second. We'll add everything in a second, so it will. Now this warning tells that we need jobs and on, but we will take care of it. Let's start first of all with the name. The name will be CI-CD pipeline. Now on push, we will go to the branches of, it's a list, so of main and develop. Now on pull request, so pull request, we will take main. We will go right here to branches, and we will put that main, and let us, yes. Now for the environment variable, so for that we will write env, and for the AWS region, we will use US East 1. If you have any other preferred region, you can use those one. For ECR repository, we will call it chat app backend. For ECS service, no environment available, chat app back and service. And for ECS cluster, there glad chat app back and dash cluster. And finally, for the container name, it will be chat dash backend, and that's it. Now let's add the jobs. So jobs. First job, it will be for building and testing. So we will call it build, and now name will be build and test, and it will run on Ubuntu latest. It will run on Ubuntu machine. Steps. Now let's define the steps. Name for our first step will be checkout code. So checkout code uses actions slash checkout at version 4 v4. Now to our next job. Now name for our next step will be setup Java 17. So set Java 17. We are using Java 17 this project. If you're using latest version, you can use those, but from Java 17 for there is not really a big difference in the stuff that you're using, so it's preferred to use the latest version, but it doesn't really matter. So uses action setup, so action set dash up at v4 with Java version, let's make it 17, and distribution, so distribution will be Tamrin, and we will Maven. So Maven. So we set it. Now let's add another step. The name will be run test, and it will run. We can use Maven, so MVN, or we can use Maven MVN for Maven Repair. We can use MVN because it would run it in a container. So Maven test dash d bring dash profiles. So profiles active. The profile will be the test profile. So we'll use the other configuration file. Now let's add another one. The name will be build jar. So it will build the jar files. And the script would already run. Now let's use run, and we will run mvn package dash d skip tests. So it will build it and skip all of the tests. Now right here, name for our final step right here will be to upload the jar artifact. So upload jar artifact, and it will use it. So it will use actions slash upload dash artifact. So dash artifact at v4 at version 4, and it will be with name application dash jar, and the path will be target slash everything with jar. So this is our jobs that we have created to our application. So great. Now let's run and set up our Docker file and commit those changes. So let's set up our Docker file for application. So Docker file. So let's change the from to Eclipse terminal -17-gre alpha working directory. Now for working directory, we'll use /app. For we will copy the target and everything with that ends with jar to and upload jar. We will expose the endpoint. We'll expose this endpoint, and the entry point will be java-jar and app.jar, and we can build that. This is the Docker file for application, and then now let's commit all of those changes to So now let's commit to GitHub. So open up your terminal, and if you have GitHub CLI, you can use this command. If you don't, just download GitHub CLI and set it up. It's real quick and really good. So gh repo create, and this is the repository name, and we will call it chat app backend. This is the backend. Now dash, this is the flag, and we will set this to public. So public dash source for our, so the source will be everything in here, and dash remote will be set to origin. So click enter. So just here, nice typo, remote and click enter, and now it will create your repository. So, and now it's created your repository. Nice. Now what we can do right here is git add. We can add everything, and git commit dash m, and the message will be setting up the application and the configuration. And this is great. And now let's click. We committed everything, and now let's push. So git push origin to main, and we push everything. Great. So we finished with our configuration, and now let's continue to set up our database. So we have finished with our configuration. Now let's continue to run our database locally using Docker and to create our DB migration using Flyway. So let's start by creating the Docker file that will run our database locally. So right here in the root of the application, you file, and it will be called Docker compose.yaml. Great. Now let's define our services. This one will be DB. For our database, the image will be Postgres at version 17 is the latest. So let's click on it. Great. Now let's give our container a name. So we'll give it the name of PostgreDB. So Postgres-_DB. Now for restart, if it will restart, we will make always. If it goes down, it will restart automatically. And now for the environment. So environment. Now we need username, password, and DB. The DB, we have our chat application, so let's start with that. Postgres_DB, and it will be chat_DB. Now in our YAML file, we also, right here in our YAML file, for our database configuration, we have the username and password. So we need to use the same ones for our environment variable right here. So we'll have the same value. So Postgres user, and we will assign it to the same user that we have right here, to the same username that you have right here. So we will copy the environment variable, and we will use it right here. And now Postgres_password, and we can just copy from here the DB password. Super simple. Now right here, DB password. So we set up our environment variable. Now let's map the port from the internal container to our own machine. So ports, let's set up port 5432 to port 5432 as well. Now for the volumes, so volumes, we'll create the volume at Postgres_data var-lib PostgreSQL-data. And let's define the volumes right here. Volumes will be Postgres data, so Postgres_data. Great. So now let's head over to the terminal and build our Docker file. Now, first of all, we need to create a few environment variables. So export, and our environment variable is db user and db password. So we can just copy it, and db username, and we will assign it to user chat. Click. Now we have this. Now we need to create the db password. So export db password and it will be user password. Great. Now let's build our Docker file using Docker Compose. So Docker Compose pose app dash t. Click, and now we have our database up and running. Now when we will run our application, it will connect to our database. And now let's run our application after we have our database, and we will see that everything is running and working. Great. So stop it. And now let's continue to our database migration and create our first migration. So it will be a new file, and this one will be the version 1 v1, and we will create the user table. Each migration, as you remember, it's like a git commit. So we want to create a different migration for different commits. So if there is any problem, we can track down the exact problem. So let's click, let's create it. And now let's create our users DB. So create table called the users. And now let's add all of the columns. So right in here, we will have the ID, which will be UUID. It will be a primary key. Great. Now we need to add the user name. It will be a varchar of 50 characters. So varchar of 50 characters, and it will be a not null value, and also it should be unique. Great. Now for the email, it will be a varchar of 255. Email should not be over 255 characters. It will be not null and unique as well. Now for the password, it will be a varchar of 1024, which is a very long string that allows us to keep long password after we hash them. It will also not be a not nullable value. And those are all of the fields for our user database. Now we can create a few indexes to speed up our database queries. So we will create index on field that we will constantly need to check, like the email and the username. So we will create index on, we call it IDX, on the user's email. And it will be on users email. Great. Now create a new one, but this one will be for the username. So username, and right here it will be username. So we'll create our first migration. Now let's create our next migration for creating the rooms. Now we are building a chat application. So in a chat application, you have a group chat, and a lot of people can talk to each other. Now, we don't want anyone that does not belong to a group chat to appear in it. So and this is why we are creating rooms. So you can know exactly who should be in this group chat and who doesn't. So let's create a new file. This will be version 2, underline, and we will create rooms table.sql. Now let's create it real quick. So create table rooms. This will be the data of the rooms, and we will also add another database for another table, and we will also add another table for the room member, not room members, so we can know who is a member in this room and who isn't. Great, so now let's first of all create the rooms table. So let's add the ID, of course. It will be a UUID, and it will be a primary key. Great. Now the name of the room, it will be a varchar of 255, as it could be very long, and we cannot limit it to 50 or something like that, so we will use 255. It will be not nullable because we must know what it is. We can also add the unique, but we don't necessarily need it. because a lot of group chat could look the same, so we will differentiate them by their ID. Now the description, it will be a description of the group, and we will limit it to 5, and it will be a varchar, and it will be a varchar of 500 characters, and it will be optional, so it could be nullable. We will also add the created by, so we know created it, which user created it, so UUID, and it will be not null, we will reference the users table on the ID column. Great. Next, we can also have the created and when the group was created if we really want it. So create it will be a timestamp. We can also make it not nullable, and it will be a default value of now when it will create it. So now. Right, now let's create the room members table. So we first of all need ID. It will be a UUID and it will be the primary key. Great. Next we will create the room. Next we will need to know which room ID is. So room dash underline ID. It will be also UUID because we're using UUID type here as well. It will be not nullable and it will reference the rooms table on the ID column, and on delete we will add cascade. So on delete cascade. Great. Next we'll add the user ID, so we know if the user ID is in here, so it will be a UUID, not null as well, and it will reference the user table on the ID column, and on delete cascade and join it, so we need to know when each table now we'll add the join it, so we can know in which time each member was joined. So it will be a timestamp, not null, and the default will be now. So not null and default will be to now. Great. Now let's add the unique on rooms ID and on user ID. So we'll know our unique values. So if there are not unique values, then we have a problem. Now let's create index on the room ID and on the user ID because we will make a lot of queries to it. So create index for the room members. So IDX room members, and this one will be on the room ID. So room, and it will be on the room members on the room ID field. Great. Duplicate it and change this one into user, and right here it will be on the user ID. Great. So we have created the rooms. Now we need to create the message and connections table. So let's create it also. Right here, new file v3 dash create message and connections table. So table.sql, right here we'll write messages. Great. Now let's create the messages table. So create table messages. First of all, we need the ID, so it will be a UUID. Right now we'll build it a little bit faster. So primary key, we will need the room ID to know in which room it was sent, so UUID as well, and it will be not nullable and will reference the room table ID, and on cascade, on delete, we will cascade. So cascade. Great. Now we also need the user ID, so we can duplicate it and just change it from room to user, and it will be reference the users on the ID file. Great. Now the content, of course, content of the message itself will be a text, because it could be really short or really long, and it will be not nullable. You cannot send a message without the content. And the send at, so we know exactly when it was sent. So it will be timestamp, not null, and it will be, the default value will be now. So great. So we finished with the messages. Let's add a few indexes. So we will create a new index for the room ID, because we will make a lot of query to that. So idx dash messages dash room, and it will be on the messages room ID. Great. Now we'll create another one to send at, because sometimes we will search exactly when a specific message was sent. So right here, send at, and it will be referenced the sent at. Great. Now let's create the connections table. So create a new tables connection connections. Great. And we will add the ID, UUID, primary key. Great. Now we need the session ID. So session ID, it will be varchar of 255 characters. It will be not null, and it will be unique for each session. We need the user ID, room ID, and when it was created. Right, we can copy right here the user ID from there. Now we'll change the room for user ID. On delete we will set to null, set the value to null, and finally when it was connected, so connected dash it, and it will be a timestamp, and the default value will be now, so not null, and default will be for now. Great. So this is our table. We need the session ID to know exactly which session we are connecting into, and this for table. Let's create the indexes for the session ID, because we make a lot of requests, a lot of queries to the database for the session and also for the users. So we will create a new index. It will be idx, and it will be connections session, like that, and it will be on the connections database on the session ID. Great. We can duplicate it and just change it from session to user. We will make a lot of calls, so we need fast indexing, and it will be on the user ID. Great. So now we are finished with our database. Now let's run and ensure that everything is working. So all of our migration are working. Now let's stop our application. Right, and now let's commit this to GitHub. So to the terminal, we will use git add all. Now we will commit this, so git commit -m for the message, and it will be flyway migration. So it will be docker. So the message will be a running the database and migration with flyway for the users rooms messages and connection tables. So let's commit it. Now let's push it. So git push origin main, and we push it successfully. And we will push it successfully. Now let's create the authentication endpoint. Now here we will use TDD, which is test driven development. We will first of all write all of our tests for the authentication controller, and then we will write the actual code. So right here, let's create a new Java class. This one will be for auth controller test to test this. Now let's add a few annotation. The first one will be Spring Boot test, and the web environment Spring test web environment, we will pick a random port so it will not clash with other ports. Next we'll add the auto configure MVC, so it will configure our mock MVC, and we will have display name annotation. Now display name is annotation that give your test much more clarity when we talk about. You could put this over a class or over a test, and it show a really nice, better looking test names than the convention that we use, like register underline should return and etc. So this one is better. So this one will be auth controller test, and right here let's start by having a few variables. So the first one will be the mock MVC, the next one will be the object mapper, and let's import it. Now let's add the auto while annotation, and right here as well, auto while. Great. And now let's add our registration test. So test, let's use the display name to give it a better looking name than the one we will give it. So it will be a post for /API/auth/register, and intro.down 201 with valid body. Right now let's create test register valid body. Now let's create the actual content. We will first of all create the register request. We will call it request. Now this red line indicate it's red because we don't have the DTO yet. We will create the DTOs after we will write those tests. So just stay tuned with that. So it will be equal and it will be new register request, and let's add first of all the name. Let's call it L, and the email will be l@gmail.com, and the password will be password123. Now let's perform the operation. So mock MVC dot perform, we will perform a post operation to this endpoint. So dash API slash auth/register. Now let's import this static method. Great. Now for the content type we will use JSON, and for the content we would use object mapper to write as a string the request. Great. Now let's put each one of those on a new line. Great. Now let's make our expectation. We expect that the status of that will be is created. So we expect the status to be created, so let's import it. We are also expecting that the JSON path for the token will not be empty because we should token exist. We will also expect the username value to be to this username, which will be in this case EL, and we will also expect that the email, not password, email, and that the value will be that email that we have right here, l@gmail.com. Great. So this is for our first test. We will shortly create the register request. Now let's create the test for the not so happy path. So let's duplicate it and let's change it. 404 with invalid body. Now it will be invalid body with the user invalid user name, and this one will be quite short. We will just change it into empty username. We will send the request and we will expect, let's change all of those. Now we will expect the status to be is better request, and also that the errors will be exist, and that it won't be empty. Great. So this for test. Now we will duplicate it a few more times for now we'll duplicate it a few times for the email and password. So the duplicate it. Now this would be invalid email, and this will be for password, and we'll just change it right here. This for the password, give it a name. This for the email, we will erase it. And there we have our test. Now let's create the tests for the logging endpoint. So right here, another test, and this one we will display name, so it would look better. It will be a post operation to /API/auth/login, and we will expect 200 OK when valid credentials. So credentials. Now valid credentials. Great. Now let's implement it. First of all, we could just copy those requests to create the user for our sessions. So let's do this, of course, with the password 123, and we will just perform this. So we will have the user, and right here we will create the login request. Now I know that we don't have it, and we will call it our request, and now this request equal to a new login request, and the login request require the username and the password. So we will use the username and the password that we have right here, which is password123. Great. And now let's perform to the login endpoint. So it will be a post to /login. The content type will be JSON, and the content itself would be the request. So object mapper, right value, request. Great. Now our expectation, the status to be OK. We'll expect the token to be exist. And that's all. It should only return the token. Great. So this is our logging happy path. Now let's duplicate it and create the not so happy path. So duplicated one. Now 400 when invalid credentials. So we'll first of all start with invalid usernames. So we will not expect to be okay. We'll expect. So right here, we'll expect not to be okay. We'll expect is bad request. Great. And we'll expect the errors not to be empty. So we will do it right here. We'll do valid credential for the username and the username. And now let's duplicate it for invalid password for wrong password. Wrong password. So wrong password and right here we'll change it to invalid username. Great. Now it's the same, just that we have the email and not the password, and we can also copy and create a new test. And this one for our completely this will be for the wrong password, which means not the password, and this one will be without the password, so without password. And now let's create a few tests for the profile to check out if the user goes to /API/auth/profile, he will get his profile. So let's create those tests. So test display name. This one will be a get method in /API/auth/profile, and it will return 401 without the token. Great. So now let's perform mockmvc.perform a get operation. And it will be to the profile, and we will expect the status to be unauthorized because there is no user. Now another test, display name for the happy path. So display name, this will be get to this same endpoint, so /API/auth/profile 200 with valid token, and for that we only need to add this annotation that with mock user, and let's have the username to be Al, and we will perform, we will expect the status to be okay. Right, so those all of our tests. Now some of our tests will fail for certain obvious reasons, because we don't have the register request and login request DTOs. So to make sure that those tests will fail, not because of those errors, but because we don't actually implement anything, we will create real quick the DTO. So right here in the main Java, we will create a new Java class. This one will be record, and it will be under the authentication package. So authentication, and this one will be for the register request. So register request. So this will be the DTO. Now it will get the string of user name, string of email, and string of password. Great. And now let's add all of the validation. So right here, no, blank, and we will add a message, something along the lines of username cannot be empty, blank, blank, also not empty, so not empty, and we'll add the same message from right here. So I just copy it and just change the end from black to empty. You can also add not null, not null, and we can add the message of cannot be null. You can also add more validation. Like this size, but you don't actually need it. Now for the email, we can copy all of those. We can copy and just change from username to email, email, and email right here as well. And also we can add one more annotation for email, so it will make sure this is a valid email. Now right here, let's copy it again for the validation for the password. We'll change it to password right here, password, and also password. Great. Now right here we also add the message, email must be valid. Great. And we also add one annotation for the size, and the minimum will be 6 characters and the maximum will be 36 because we don't want too long of a password. And the message will be password must be between 6 and 36 characters long. There is a typo, so let's fix it with IntelliJ. Great. So this is our register request. Now for our login request, we should create a new Java class. This one will be inside of the DTO. We also need a DTO, not just the auth, so it will be login request. It will be a record, and also let's move the register request to this DTO folder. Great. Now we can go into the register request and copy all of this because it's very similar, but we don't actually need the email. And yes, that's for it. And now for the auth controller, let's import those ones. Import. And for the login request, let's import as well. Now if our test fail, it won't be because of a syntax error or some class or DTO does not exist. So let's run it, and you will see that all of the tests will have a red bar and will fail. Now let's create the actual code that will make those one pass. So let's create our auth controller. So first of all, we need to create a new package for the users. So not under the DTO, so for the users right here. Let's create our entities. So new Java class. This one will be for the user. Great. So now let's do it real quick. So first of all, the entity annotation, now the table annotation, and table name will be users. Great. Now let's add the getter and setter. So getter, setter. Great. All arg constructor, no arg constructor, and the builder to use the builder pattern. Great. Now for the ID. So right here ID generate status will be UUID, and it will be a UUID type. Great. Now let's check out exactly how it's look like. So we have a username and a password, very simple database. So private string username, password, and email. Now we can add a lot of validation to the entity, but all of the validations are at the database level, so we don't actually need to create them. Now these users will implement user details for the security. So let's implement the method. So let's create all of those. Okay. Now for the get authorities, we don't actually need it because we are creating a chat group app and we don't actually need a role. We don't want an admin user on over the application because each user has their own group chat. So this is unnecessary actually. Log to return false. Right here is credential not expired. We will return true. The credential is not expiring. And right here is true because it's none. And it is enabled. We will also put this to true. Great, so we implement the user detail right here, so we can use it. So now let's add another one method, or this one will return a string, and it will be to get the user name, and we will return the username. This will be for Spring security that will use this as the principal name. So we will return the username so that the JWT subject will be matched. So let's go and create our repository. So in new Java class, this would be an interface and it will be user repository. Right? It will extend the JP repository and it will be a repository annotation to test bring the desired repository, and the type of the ID is UUID. Great, now let's create a few methods. Optional find by username, find by email. Great, we can duplicate it and find by email, and it will search for the email, and find by ID we already got, and we also want a boolean exist by username and exist by email, so we will know that as well. So this is for our user. Now for our DTO, we create the register and login request. Now we need to create the response. So right here, new Java class, it will be a record and it will be the auth response. Great. So now let's add the auth response right here. It will be auth response and it will be a record. So to make it a record, that's all we need to do. It will return the token, username, and email. So just that. So we have our DTO. So let's close it up, the DTOs. And now for the security, let's create the JWT. So new Java class, we need to create JWT. So JWT service. Now it will be at the security JWT folder. Great. So let's click enter. So we will add the service annotation to it. So this service annotation for Spring Boot. So now let's we need to add a few variables. First of all, we need to add a few fields. The first one will be the secret, so it will be a string for the secret, and we also need one for the expiration. So right here from token to expiration. Great. Now we'll inject those using the value annotations. So value, and it will be in here under JWT secret. Great, now copy it. And let's add this annotation right there. And instead of the secret, it will be the expiration. So expiration. Great. So it will take the expiration and the secret from the YAML file. Now let's create a few methods. Now let's create a method for generating tokens. So generate tokens, not for this, and we will get a user. Let's import it and we'll call it user. Now we will return JWT builders, and for the claim we will add the user ID. So we'll call it user ID. Right here we'll add user.getID, and we will set the subject to the username, so it will be the username. So user.getUsername. Now we will set issue at, and it will be a new date, and we will set the expiration. So set expiration and new date, and we will use system dot current time in milliseconds, so we'll get the current time, and we will add it the expiration time, that is also in millisecond. Now we will sign with, and we will create this method in a bit, which we'll call get sign key to get the signing key, to get a secret, and we will compact. Great. Now let's create the get sign key method. So right here it will be a private method. So private, it will return secret key. We'll call get sign key. First of all, we will encode the key. First of all, we will decode the key. So bytes array. This will call key byte, and it will be decoders base 64, and we will decode the secret, and we will return. So return is dot I can read it. It will this method name with the key byte, and yeah, we have it right here. Now let's create our other method. This one will be for parsing the claims. So it will be a private method for parsing the claims. So it will return the claims, and we could get claims for token, and will return jwt.parseBuilder.verify. And now let's implement the method. So jwt.parseBuilder.setSigningKey to this. We get signing key, we will build it, and we'll parse the claim from the token, and we will get the body. And now let's extract the username from that. So public ring, and we call it get username from token or extract token, both work, and we will return the get claims from token, and we will get the subject. Great. Now we need to write the checks to make sure that the token is still valid. So first of all, we need to create a private method to check out, that will return a boolean to check out if the token is expired. So it will return, and it will get the claims from the token, it will get the expiration time, and if it will return true, which means that we are before it, so this is our so we will get the claims, get the expiration, and ensure that we are before the new date. Great. Now let's create the isValid token method. So it will be a public boolean isValid token, and we'll get the token and also the user. So right here we will take the string of the username, and we'll get username from the token. We'll make it final fit so it could not be altered later, and we will return if username equal to user.username and the token is not expired. So and is token expired, and the token should not be expired. Right, so this is for our JWT service. Now let's create our authentication service. So right here, new Java class, we will call it auth service. Now let's add the service annotation service and require our constructor. Great. Now we need user repository. So user repository, password encoder, and JWT service. So JWT service. Great. Now let's create the register method. So public, it will return an auth response, and it will be called register, and it will get an register request, and we'll call it a request, and it will be a transactional. So we need to add the transactional annotation. So if any of this doesn't work, it will roll out. So now let's check if the user repository dot exist by email and the request email. We will throw a username, we will throw a new arrow, and this one will be user already exists. So user already the exists exception with the message of email is already in use. So email is already in use. Now we actually need to create this exception. So right here, new Java package, we'll create it in exception and we'll create it under the exceptions and we will call it user already exists exception and it will be super simple. Great. So now we just need to import it. Now let's duplicate it, this time for the username. So exist by username and let's pick the username this time and we will use username is already new. So now so if we pass this, we can create the user. So user and we will create new user. So user and we will use the builder pattern for it. So user.builder and now let's build it. So first one we will have the username. So the ID won't be because we don't need it right here. Request username and email will go from the request and the password will came from the request as well. And now we can build. Now for the password we need to encode it. So let's use the password encoder, encode method and let's encode it. Great. Now we will save the user and we will save it in this variable that calls saved and we will use it to generate the token. So string token derivative create token. Great. And now let's return a new authentication response with the token with first of all the username. So save.username, email and token. Great. So this is our registered method. Now let's create another transactional method for the login. This one will be for read only, so it could only read data and could not change any of it. So first of all we'll find the user equal to user repository, find by username and we will have from the request we'll have the username. But if we don't have it we will throw, so or else throw and we will throw invalid credential exception. So new invalid credential exception with the message of invalid credentials. So you can copy it like this and space invalid credentials. And now let's create this exception right here in the exception, new Java class exception, give it a name and that's all. Now we need to import it, import class. Great. Now we need to check if the password is matching. So if the password match, if our request password match the user's password, if it doesn't match it, we will throw invalid credential exception. So in both of them we will return the same errors. And you already know why, because for the security reasons, because we don't actually want to expose exactly which data was wrong. So if a malicious user will come, he will not be able to take advantage of the website, or he will not be able to take advantage of this. Now let's generate tokens. So string token and we will return the response. Great. And this is for our user service. Now let's create our authentication controller. So right here, new class, and it will be auth controller. Great. Now let's add off the annotations. So first of all, REST controller, request mapping for /API/auth and require our constructor. Now we only need the authentication service right here. Now for post mapping, this one will be for the register. So let's add register and let's create the method itself. So it will return a response entity. So response entity with the type of response. Great. And we will call it register and it will take from the body. So from request body, this request from the register request, and we will use the valid annotation to ensure that the request is valid, not empty, not null, and not blank. So right here, let's implement it. So we can actually return just from here. So return a response entity with the status created. So receive as created, and with the body, we will use the registered method with the request. Great. So as you can see, super simple. Now for the post mapping for the login endpoint this time, so it will be login, so it will return yes, a login response just like that, and we will return this. We can also remove this and could use just the OK method with the body. Great. And now let's create the profile endpoints. So to get a profile, so it will be a get mapping this time, and it will be to slash profile. Great. Now it will return not an authentication response, but a user response DTO. So let's create it real quick. It's a DTO that we are creating to not expose certain parts of the application. So like the password and so on. So it will be a record. This will be the name, and it will be very simple. It will have the UUID ID, username, email, and we won't give the token. Great. So authentication. Now let's import it, and we'll use the authentication principal to get a principal of type user. Great, because we implement the user data service in it. So great. So now we can just return response entity with the type of OK, and it will be a new user response, and we will add all of the parameters like user ID, so get ID, user username, and get the email. Great. So we implement all of our endpoints. Now let's go to our tests and run it. Now we need to create the authentication filter for JWT. So right here, create a new Java class. This one will be for the JWT authentication filter. It will extend the once per request filter, and we'll add the component annotation to it. Great. Now we need to implement the doFilter internal method. So let's do that right now. So before it, we need to have a few fields. The first one will be for the JWT service, and the next one will be for the user repository. So user repository. Great. Now let's use the Lombok annotation for the require constructor, like in Magic. Now let's implement the method. So we'll have a final, so it cannot be changed later. Authorization header, and we will get the header from the authorization. Now, if the authorization header is equal to null, or the authorization header does not start with a bear, which means this return false, it will convert it to yes. We will do the filter and return. So now let's create a string for the token. We will cut the first 7 characters, which is the bear and the space. Now let's take the username. So we'll take the username from it, and if the username is null, so if username is not null and the security context, also security context holder get context authorization is equal to null, if that's happened, we'll go right here and we will go to the user repository. We will find by the username, and if it will be present, which means if it will be exist, we will go right into this method. Now if JWT service validate token, and we'll get the token and the user. If it evaluate to true, so we will use username password authentication token, and we'll use new username password authentication token with the username and the author, but we can remove all of this long one and use just a var. It's more suitable for this case. And for the security, we will set authentication with the authentication that we have right here, that we set right here. We will set authentication. So we set it to var, which is more suitable in this case. Now we can click on that, but before that we need to do one thing first. Authorization.set details, and we need to use the set details, and we will use a new web authentication detail source, and we will build the detail with the request, just like that. And we also put the authentication in, we set the authentication in the security context holder. Great. And yes. And after that we will filter chain, do filter. We will just need to move it up. Yes. So this is for our authentication filter. Now we need to configure to go and do the security configuration. So right here we need to add new. We add new Java class, and this one will be for security config. This will be for the security configuration. Now this shouldn't be in the JWT ones, so we will adjust that to be in the right folder. So not slash security. Great. So this is our security configuration. Now first of all, configuration, enable web security, and the require our constructor, because we will need the user repository and the filter. So fire our constructor. Now private user repository and the JWT filter. So JWT authentication filter. Great. First of all, let's take care of the password encoder. So it will be bin, and this one will be for the password encoder. So it will return a new bigquery password encoder, and let's just import it. Great. Now let's configure the user detail service. So user detail service will configure it. So we'll return this function. All right. So username goes to here. User repository dot find by username, and we'll put the username and or else, and if we don't have it, we will throw or else throw this exception. Let's move one line down. This will be new user not found exception. So username not found exception. Great. So we configure a few bins. Now let's configure the main bins of the security filter chain. So bin, now it will be for the security filter chain, and it will be a security filter chain, and it will get HTTP security. So HTTP security, and it will throw the exception. Now let's return HTTP dot CRTSRF. Now we will disable it. So abstract method configuration. So we'll use the method reference. So abstract HTTP configuration, and we will use the disabled method for the graph. Great. Next, we will go into the session management. Now session management, and we will set this to session, and we will set it to session and disable it. Next, we will go into the session management, session the session creation policy, and we will use session policy state. Great, let's close it so we have more space. Next, we will use authorize HTTP request. Authorization, go right here to authorization dot request matcher. Now every request that match slash API slash register and also slash API slash auth login, we will permit, and every request that will match WS for WebSocket, we will permit it as well. So permit all. Any other request, we will need to authenticate it. So any other request, authenticate. Great. Now we need to add the JWT filter. So add filter before JWT authentication filter, username password filter class. Yes. And we will build it. So we handle the filter chain. And finally, we need to add the bin for authentication management. So public authentication management. So it will be DAO authentication provider, and we'll call it provider. We'll assign it a new the authentication provider, and it expects a user detail service. So we can use the user detail service method that you have created earlier right here. Now provider does set password encoder, so we will set the password encoder to this method, and let's return a new manage provider with them, and we can just return the provider. So those are for our configuration, and now we need exception handler because we have a lot of exception that we throw and we don't want our application to stop every time. So for that we are using a global exception handler. So it will be a new Java class, and it will be inside the exception. It will be inside the exception package, and it will be called global exception handler. And great. Now we'll add the REST controller advice, which tells Spring Boot that it will advise the REST controller what to do in that case. So this is how we are handling exceptions. Now before we handle it, let's create a little DTO for the exceptions so we can return a clear response. The first, and we will call it error response. So real quick, let's add, first of all, we have an integer for the status, string for the message, and finally a map of string and object for the error. Great. Now let's handle those exceptions. So right here, exception handler, we will handle the user already exists class exception. We will return an error response, and now let's return a response and a response entity. Let's set up the status to HTTP status conflict, and let's set the body right here. It will be a new error response, and it will be with the status of 409 with the exception message, and let's set the errors to null. Now for invalid. So invalid credential exceptions, and let's return a new response entity with status of unauthorized. So let's set this to HTTP status unauthorized, and let's set up the bodies. So yes, let's make it one liner too. Now let's handle a few more exceptions, like method argument not valid. This happens when someone trying to return to do a put, let's say, for our authentication endpoint, which obviously we don't have, so it will return a argument not valid. Now let's handle the next exception. Will be for method argument not valid. This will come from the validation that we do. So now let's return bad request with 404. And for this one, we don't actually need to return null for the error. We actually can get the error. So it will be map of string on string. It will be for the errors now. Exception. Now all errors. For all of the errors, let's go into this small method. String fill. So we will get the fill and we'll put it in the errors. So write that, and right here we will return the error. So we have string and string. Yes, a string is also an object. Now for all of the rest of the exception, we will return internal error, so 500. Now there will be more exception to handler as we will extend the application, but for now it will be sufficient enough. Now let's go to our test and check out. Now let's go on and run the test. Now forget something here for the active profiles, that we will use the test profile. Great, now let's run it, and everything is working. Great, so we implement the authentications part. Now let's commit everything to GitHub. So let's go to the terminal, git add all, and git commit -m with the message authentication controller completed with the test security JWT and filter change. So this is the message. Now let's commit it. We committed. Now let's push it to GitHub. So GitHub push origin main, and we push to GitHub. Now that we have finished with all of the user and all of the least interesting stuff, let's go over and create our chat. Let's start first of all with the rooms. So for that we'll use the same technique that we'll use the test driven development. So first of all, let's create our test. So right here, new Java class, this will be for the room controller test. Let's add all of the needed annotation. The first one will be Spring Boot test. Next one will be auto-configure web MVC. Next one will be for active profiles, and we will set it up for the test one. And also display name. We will display the room controller. Great. Now we need a few fields. The first one will be the mock MVC. The next one will be the object mapper, and final one will be the room service. Yes, I know what it sounds like. The airline is there because we don't actually have it yet. So we will deal with it now, and we will implement it in a bit. So first of all, we need to auto-wire those ones. So auto-wire this one and auto-wired. And for this one, we need to use the Mojito bin, and we also need another field which will be the room sample room. So it will be a room response, and it will be a sample room. So we could test. Great. We will create those in a bit. Let's just set it up. This sample room will be equal to room response, and first of all, we will probably have the ID. So let's set it up. First of all, we need the UUID, the identification. So we will choose a random UUID. But before that, we will need to use this UUID, this random. So let's extract it to a field. So private UUID room ID, and we will set it up right here. Room ID will be random, and we'll use the room ID. Next, we will give it the name. So the name will be room 1, and also description will be room 1, and is private we will set to false. And now we need another ID, this one for the user that created it. So another field, we'll change it from room ID to user ID, and right here it also will be a random UID. So right here is the user ID. And finally, for create it, we will create a new day. Great. So we did the setup, and now let's create our test. So the first one, it will be test. It will be for the get endpoint at /API. It should be a string. So it should be a get at /API/rooms, and it should return 401 without authentication. So 401 with authentication. Because we don't have any mock user like we will do in the other test, we will use a mock user. So we want users right here to test it. So we get rooms, and it should return 401 without authentication. Great. Now let's go Mojito in. Let's perform. Now let's perform the get operation. So get, and we will expect the status to be is unauthorized. Now for our next step, we will expect to be authorized. So this one will be with mock user. So with mock user, and to return 200 with authentication. So with authentication and 200. Great. Now before we will perform this, first of all, let's use the Mojito to make a mock response. So when the room service will call to the method of list rooms, it should then return a list of sample rooms. Great. Now all of those errors happen because we don't actually implement it yet, but bear in mind we'll implement it in a second. Now for the status, we'll expect it to be okay, and we also expect that the JSON path for the ID will be room ID, and that the name will be not. This is the description, it will be room 1. Yes, now let's create a new test to check out the post method to create new rooms. So this one will be, it will be with mock user and display name, and it will be for post at /API/rooms, and it should create the new room. Create new room. Now let's create the request. So it will be a create room request. We don't have this DTO yet, but we will create it in a bit. It will be new create room request that that will have a few fields. First one will be the name. So the name will be room 1. Let's take for example. Description will be room 1 as well. And we have is private right here, the field, so we'll set it up to great. Now when the room service will call to the create room method with any argument of any type, and we'll have 2 arguments in it, we should then return the sample room. Great. Now ignore those errors, those will be gone. In a second we will actually implement the method. Now mockmvc perform a post operation to the rooms, and the media content will be application JSON, and the content itself will be the request. Great. Now we will expect the status to be is created, and the name value to be room 1. Great. Now if we don't have the name, we should have an error. So let's duplicate it and change it into 400 error without the name. Great. And now let's remove room 1. Let's return, and we should expect to be is bad request. Great. Now let's create another test to see what's happened when another room is already exists. So create rooms, and in this one should return 409 when the room name is exist. Great. Let's change this into new, just one without name, and this one create room with existing name. Great. Room 1. Let's remove this from here. Now to this. Now right here, instead of then return, we will then throw a new error of room already exists exception. So exception with the message of room already exists. So this is for our error, and now we should expect the response to be is conf. We will also create this room already exists exception. Now let's test with mock user, and the name will be a post operation to join to the room slash ID right here slash join. This one will be 200 to join for the room. So okay, join to the room. Great. Now let's create the mock when the room service will call to the join room method. So join room method with, it should take 2 arguments with any and any. We will then return the sample room. So the sample room. Now let's use the mock MVC. Let's perform a post to the ID and let's expect that the status will be okay, and the name, let's use the name value will be room 1. Great. Now finally let's create another test when the room is not exist. So right here, join 404 not found when room does not exist. Great. Now we will then throw this new room not found exception. So not found exception that we will create in a bit, and the message will be room not found. And right here, instead of the ID, you will just put non-existing ID. Let's remove this, and we'll expect the status to be is not found, and that's for our test. Now if we run the test right now, they will fail for the obvious reason that this whole code does not actually exist. So let's create the DTOs really quick. So the test will fail not because of those errors. So let's start with creating the room service. Let's start with creating the room response. So right here in the main Java, let's create a new Java class. This one will be in the package of rooms, and this one will be in the DTOs package, and it will be called room response, and it will be a record. Now the response should have the UU ID for the identification, a string for the name, a string for description, a boolean for is private or is private, and the UU ID for the user that created it. So UU ID for created by, and the ID of the user, and the time of creation. So local date time. This will be created. So this is for our room response. Now let's go over and import the room response. Great. Now we need to create this next DTO. So create room request. So room DTO right here, new Java class record create room request, and we will have 3 things in here. First of all will be the name, so string name. The next one will be the description, so string description, and the final one will be a boolean of is private. Right now let's add a validation. Although all of those, the first one it will be, this will be not blank, and let's add the message of room name is required, and this would be it. We can also add the not blank, so not empty and not blank with the same message. So not blank, yes, we can add those one into the description as well, and this doesn't really need any validation. We can also have the size annotation, so size, so it could not be over maximum of 500 characters long, so 500 characters. And we can have the message of description must be under slash equal to characters, so characters. Great. We can also take this size here as well, like name must be under 50 or 255, and great, and this will be max of 55 characters as we did in the. So this is the create room request. Now let's import it. So we can import it. Great. Now it will be create room request next. And now for the exception, room not found and room already exists. Let's copy it. Let's create a new package right here, and it will call the exceptions, and right here we'll have all of the exceptions. And let's create a new Java class with the exceptions. So exceptions, room already exists. Great. Nothing more to do. And room not found, let's create this one as well. So Java class, it will be an exception. Exception are really easy to create, so let's import them. Just import and import. Now all that left is the room service. So new Java class for the room service. It will be a service with the wire our constructor. We will implement it in a bit, but first of all we can actually import it, and we need to create a list of rooms and all of that stuff, but we will create it shortly. So as you obviously can know, those tests will not pass and will fail because we don't actually implement the code. We can run it, but this failed because we don't have part of it. So now let's create the actual code for it. So right here, let's create the room. So room entities. So room, let's add all of the annotation. The first one is the entity. Now we'll have the table, and let's add the name will reference to the rooms table. Now getter also all our constructor and no org constructor as well, and also the builder panel. Great. Now the ID, it will be UUID, and the creation type will be also UUID. Great. Now let's see what columns do we have in the rooms table. We have the name, description, private, created by, and created at. So right here we can have the name. We don't need the column actually. The name, the description. We also have is private, created by, and created at. So a boolean or is private and created by and created at. Now this is one of the occasions that we will use the column annotation, and we'll find the name, which will be created by, and we will call it user ID, maybe just user, and right here we'll use the user. Now we need to use the many to one because there could be many chats but only one user, and this is the one, and also the join column. And let's set up the name, and now let's set up the name to be created by, so created by, and we don't actually need it. Great. So this is for the user. You can also call it created by. Doesn't really that matter. Now for the is private, we will use the builder.default because there is a default value of false, and also there is a default value for the created edge. So the default will be new, will be the local data time. Now created is not a UUID, it's a local data time. Yes. Now right here we have the room's member. In the room's member we have the room ID. Now the room ID. Now the rooms should know about the room members. So there is a relationship between them. So let's set the relationship. So it will be a private set of user because set of room members because each one of them will be different. So room member, you will create this entity shortly. It will be called members, and it will be a new hash set. So new hash. Great. Now let's add the annotation. The first one will be one too many because there is one room for each member, but there could be many members in each room. Now it will be mapped by the room, and for cascade it will cascade type all, and often removal will be set to true, and we will use builder default. Great. So we have the room entity. Now let's create the room member entity, and then we will create the repository. So new Java class for the room member. So we'll have the entity annotation and also the table annotation, and the table annotation with the name will be set up to room members, and all of the other annotation like getter, setter, all our constructor, no constructor, and builder. Great. Now we need the ID. So the ID, not long ID, it's UUID. And right here it's UID as well. Now right here we can see that in the room members entity we have the room ID, user ID, join field. So let's go right here. We'll have private room. Now let's connection it. This is a many to one. And we'll use a lazy fetching, and we will join column on the column name of room ID. Great. Now the same we'll have for the user. So private user import the user from auth many to one lazy, and also join columns with the name of the user ID. So user Okay, great. Finally, we have the join ads. So private local time data join add, and the default value will be now, and we'll add for the builder. This will be the default value. And in the table configuration, we need to add one more thing before we'll go. It will be the unique constraint, and it will be on the unique constraints, and the column names will be the room ID and the user ID. So user ID. This is the rule that you have right here, the unique constraint. This is the one. Great. Now we finished to create the entities. Let's create the repository. So right here, new Java class. It will be an interface. It will be the room repository. It will extend JPA repository with a room member and a UUID. Yes, and let's add the repository annotation and a few queries that we might use. The first one will be a list of room. Let's import it, and it will be called find. It should be a room, not a room member. It should be called find by is private false. So we should find where all of the rooms are not private. And also a boolean if for exist room by name, and string for name. Great. Now we can remove those unnecessary imports. Now let's create a repository for the room member. So right here, new Java class, new repository. This will be the room member repository. Great. We will extend the JPA repository again with a UUID and the repository annotation, and we'll add another method, a boolean exist by room and user. So exist by room and user, but not user ID, by room, because it took out for the room as we set it up in the room member right here. Great. So now let's close those. We still did not implement it. So now let's start to create this room service after we create the repositories and the entities. So we need two fields right here. The first one will be for the room repository, and the second one will be for the room member repository. Great. Now this method will return a list of room response. So list of room response. Great. Let's import this class, and we'll call it list rooms. So list rooms. Great. Now we'll return. So let's return the room repository dot find is private. So we find is private false, all of the rooms that are false, and let's use the stream to map each object to our response. Now let's create this method right here to respond, and now we need to map to our response. So let's create our mapper. So new Java class, it will be in the mapper, and it will be an interface that will be called room. So it will be a room mapper. So let's create this interface. Now let's add one method that should return a room response. So room response to response, and it will get a room. Let's import the room response. Great. Now we can implement it. Let's use the great. So now let's create the actual implementation. So room mapper implementation. Now let's implement room mapper. Now we need to implement the method, and we will use the service annotation to tell Spring to inject. Great. Now we need to create a new user response. So we will return a new room response, and we will use room.getID, room.getName, room.getDescription, room.isPrivate, room.createdBy, and get ID. So room.getCreatedBy, and we will get the ID. And finally, room.getCreated. Great. So we create the response, and now we can use it in the room server. Right here, let's add a new field. So for the room mapper, so we can use room mapper to response. And lastly, we will make this into a list. We can also make each one on a new line, and this is our list room. As you can see right here in the test, it's already working, and we have it. Great. Now let's continue to our next method. Now this method is transactional and should be read only, so any data could not change. Now the next method would also be transactional but would not be read only, because we will create a room. So it will be a room response, and it will be create room. It will be create room, and we will get a create room response. So create room response request, and we will call it just a request. Now let's implement it. First of all, if room repository dot exist by name and the request dot name, if this is evaluated to true, we will throw not this error, we will throw new room already exists. So room already exists exception, and we said something along like room plus request name already exists. Great. If we pass that without the exception, which means we doesn't have the room, so we will create it. So room, we will create the new room using the builder panel. So room.builder, first start with the name. The name will be request name. This private will be private. The description will be room.description. And for the created by, we need to use the creator, which will be a user, which we'll add as an argument. So user creator. Great. Now let's import the user. Great. Now let's save it. So room, we will call it saved. We will call it saved, and we will use the save method to save the room, and we will also use the room member repository, and we will save the room member dot builder. We will use the builder. We will use the room. Saved. The user will be the creator, and we build it. So we also do this, and now we will return to the response. So with the room mapper. So now we have two methods right here. Now we need the join room method. So let's create it. It will also be a transactional. It will return a room response, and it will call join room, and it will get the room ID and the user, not user ID, but the user itself. Now let's find the room. First of all, let's find the room. So room equal to room repository, find repository dot find by ID, and we will add the room ID. So room ID, and if we don't have it, we'll use or else throw, and we will throw this exception. So new room not found exception. So room not found exception with the message of room not found. So room not found, and we will add space and the room ID. Not actually need to do that. We need to use the new keyword as well. Now if the room member repository dot exists by room and user, and we will have the room and the user. Yes, now we need to change this just to our room, not room ID, and right here also to a user. Right, now let's go back. Now if this room is not exist, we will create a new room. And now let's go to the repository, and we will save it, and in the end we will return the room to response. So we create all of the method, and now we don't have all of those weird error. We need not a new date, a new local time data. We need the local data time dot now right here. Yes. So now if we run the application, it will fail because we don't actually have the endpoint yet. So it failed because it couldn't reach the endpoint because we don't have the controller. So let's finally create the controller. So new Java class room controller. Now let's create it, and let's just do it real quick. So first of all is the REST controller. Second of all, it will be request mapping, and it will map it into /API/rooms. Finally, we will have the require our constructor. Next, now we will use not the room mapper but the room service. Yes, I know it sounds funny. Let's remove this unneeded import. Great. Now we will create the get mapping to get all of the rooms. So it will be our response entity, and it will be list of room response. So list of room response. Yes, and it will be called list room. Nice. And we will return our response entity, okay, with the room service with the list room method. Nice. Now let's use the post mapping to create a new room. So public response entity, this will be the return type, and it will be our room response, and it will be called create room, and the arguments will be the user, the principal, and the body. So in the body we will find request body, and in the body we will find the create user request with the request, and we will use the valid to ensure that this is valid before it would reach our controller, and we will use the authenticated principal to get the user. So user, great. Now for the method itself, we will simply return responsibility okay with create room of request and user. Now lastly, we'll create the post mapping for joining a new room. So we'll have the ID right here and also the join. Now we will return a room response and it will be called join room. Now we'll have the path variable. Let's take it. So path variable, and it will be UUID. Great. And we will take the user. So authenticated principal of user. Now in the method itself, we will return a response entity okay with the join room with the ID and the user. Great. Now let's go out and check out our test. So right here, let's run them. So all of our tests are failed, and this is because we did not add to the exception global exception handler. We will not add the new exception that we have created. So exception handler, and this one will be for our new room exception that we have created. So we will create for the room not found exception, and room already exists. So for the room already exists, we will return with the status of conflict, and the body will be not for 409 get message and null. And we will also create an exception handler for the room not found exception. So for room not found class, we can click tab, and yes, it's correct. So we add the global exception handler for those two exceptions. So let's rerun the test. Now those arrow, if you scroll, you will see that it was expected 201 and we return 200, and right here we return 404 when we return internal error, server error. So let's fix this. Let's first of all fix this problem when we should return 201. So room controller, we return okay when we created, but instead of that we should use the status, and this will be and status, and this will be the body, but the status will be HTTP statuses and will be created. Now let's run the test again, and now we have two failing tests. So let's figure out what was the problem. Now the problem was that it expect 200 but got 500. So let's go check it out. Now to solve those errors, let's go to the controller and see what we can spot. Right here, the autocompletion was put and not post. So let's check it out if this was the problem. This was the problem for one test, but we still have this problem. So let's check out what was the problem. Now this is in this test. We should expect 404 is not found. We will throw room not found exception. So when we throw room not found exception, the exception handler should catch them in a room here, room not found exception class. It should return 404 not found. Maybe we'll add the response status not found. Not found. Let's try it out again. So as you can see, this is still not fixing. So let's try and sniff around. Now right here, I think I saw the problem. Right here, we are using non-existing ID, and this is not valid UUID. And when Spring Boot will validate it as a path variable right here, it's not a UUID, and then it would raise the error. So let's go and change it. We will change it again to ID right here, and we will put in the ID, we will put the user ID to string. And in this case, the UUID will still be wrong, but it will still be a UUID, and Spring Boot will not complain about it, and Java especially will not complain. Let's run, and yes, this was the problem. Now everything is working. Now we build this API using test-driven development, and we also experience debugging. We find the error, we debug the application, and really got to the bottom of our problem and fixed those. So now let's make the commit, git add everything, and now git commit, now with the message of finish with the room test-driven development controller test entities service, and finally we created the controller. So controller with all the path. So let's commit. Now let's push it to GitHub. So git push origin main, and we commit to GitHub. Now that we have finished with the rooms, we need to build the most important part, which is the actual chatting. So for it, we will use WebSocket. This time, we won't use the test-driven development. We will use the method of test after development, which is probably what you will do most of the time when building a real-world application. So first of all, we will start by creating a few DTOs that we will use. So right here in our main file Java, we will create a new package called message. So messages. And right here we'll create a new DTO. So it will be a record and it will be for the chat message. So chat message. Great. Click enter. And in this record we will have the UUID for the room ID. So room ID and string for the content. And we also need a type that we will create right here. So right here. Let's create an enum for the type. So public enum type, and it will be a send, join, leave, or error. So this will be the type. And right here we will use this type. So type, and we'll call it the type for the connect. Now let's create our next DTO for the chat message response. So right here, create new Java class record, and it will be for the chat message response. Let's create it, and the response will be the UUID for the message, user ID, room ID, users, and content. So let's start by creating the message ID, room ID, user ID, string for the username. Now for the content, so string content and local data time, no timestamp, it will be send. Now let's create the connection manager. Right here, let's create, but before it, a new package for the TTO. Let's put those one right here and refactor. Now before we will move them, let's create a new connection. So connection manager. Let's create this class. It will be a component. So let's use the component annotation. Let's move those records to the DTOs. So let's create a few fields. So it will be a final, and it will be a map of string and WebSocket. Now let's use the require hours constructor. Great. Now another field that we need will be map. Now we need to initialize this field. So it will be a new concurrent hash map. Great. Now for another field, it would also be a map of string, but this time and also users, and it will also be a concurrent hash map. Now this will let's call it session users. So session users. Great. Now for our final field, so another map of string and another map of UUID, and for the identification, and for set of string. This one will be for the room session. So let's import this class as well. So room session and new concurrent hash. Great. Now let's create a few methods. So the first one will be void, and will be to add session. It will take a WebSocket session, user, and the room ID. So user and the UUID for the room ID. Great. Now let's put this session get ID and session at the session at the user. We will put the session ID and the user, and the auto completion is quite spot on. For the room session, we will use the complete if absent room ID, and go to this function. You can call it also key. Now for concurrent hash map, so concurrent hash map new reset, and we will add the session with the ID, and that's all. We don't need the username. And right here we will add the session ID. So session get ID. Great. Now this is for this function, for this method. Now for removing session, we need the session itself, and we first of all need to retrieve the session ID. So we will get the ID. Now the user, session user, and we will get by the ID. Now session remove session ID, we will remove the session ID, and room session dot value. For each and one of those, will make this function and we will remove the session ID. So we iterate on each and one of them and remove the session ID. Next, we will create the getUserFromSession method. So it will retrieve a user. So getUserFromSession, yes, and we will have the room ID. And next, let's create the getUserFromSessions. So user get user from session, and we will get it from session ID. And finally, let's create the final method, which will be void and will be to broadcast to room. It will have ID and the payload as well. Now let's implement it. It will be a set of string for the IDs, and it will be room session dot get our default. So get our default. The first one will be the room ID, and the second one, or the default, will be an empty set. Now IDs, we will iterate on them, and for each session ID, we'll go to this function. So WebSocket session, and we will get with the session ID. Now let's check out if session isn't null, and session is open. In that case, we will use the session dot send message, and we will create a new message with the payload, and we will surround it by try and catch, so in any case that we have an error. So this is our functions and method for the connection manager. Now let's create message entity and a message repo, because we need those one for the message service that we will create in a bit. So let's add all of the annotation, the entity, the getter, the setter, the all, the noAuth constructor, the builder as well with the annotation, and now the table annotation. And let's add the name and let's set it to the message. Great. Now let's create the ID. So ID will be a UUID. Let's import it, and we'll use UUID right here as well. Now let's give a quick check right here to how exactly this look like. So in our chat table we have the ID, room ID, user ID, content, and sent. So we have user for the user imported. We also add private room for the room, and also local time data. Now let's use the method1, and right here method1 as well. And now let's use the join columns, and for the name, because we are using right here room, and it's called room ID. And also right here we will join columns on the user ID, so name ID. Great. So we have our first entities, and for that, for the builder, we will use just the default value. Now let's create our repositories. So new draw class interface message repository. We will extend the JPA repository with the ID type of the ID and the repository. And now let's add one method that will give a list of all of the methods. So list of message, and will be called, let's import it, find by room ID, and all them by sent at descending order, and we will get ready, and also the page about. Now let's create a message service. So new class, it will be called message service. Let's add the service annotation and the require house constructor annotation. We will use the message repository, the room repository, and also the user repository. Now let's use the transactional, because this will be a transactional operation, and will be public message save, and it will get the UID for the room ID imported for the ID, for the user ID, and the content. So content as a string. First of all, we will find the rooms. So room repository find by D or alice, throw room not found exception. So new room not found exception with room not found, and we can also add the room ID. So plus room ID. We can do the same for the user, throw a new illegal argument exceptions with user not found. Great. Now let's create the message. So message, and let's use the builder. that we have. So, and let's build it. So, room, let's set up the room, user, and content. And now let's save it and return. Great. Next, we will use another transactional but for read only, and this one will return a list of message response. We will create it in a bit. So right here, let's create in the DTOs and a new Java class called message response. It will have a UID for the ID, one for the room ID, user ID, one for the user ID, string for the user, string for the content, and local data time, and now let's go back into the message service and import this class. Great. Now this method will be to get all of the chat, so it will be actually to get the history, and we will need the room ID and the pageable. So let's import the pageable. Next, we will use the message repository, find by room ID or hotel by sent at descent, and we'll add the pageable. Next, we will use the stream object and the map object. We need to map those one in and then to save them to a list. Now we need to map them to a message response, which should look something like that. Message goes into this. It will be a new message response, and we can add message dot get ID, message dot get room, get the ID from the room, message dot get user, and we will get the ID from the user, and we will need to get the content. So message get content, and finally message dot get sent at, and now we also need the user, so the username, so message get user get username, and that's all. Now it's a pretty long function, so let's extract it into a mapping that we should have. So it should be in the mapper package, and it should be the message mapper, and it will be an interface that will define how it should look like. It should return a message response, and it will be called to response, and it should receive a message. Great, now let's implement that new Java class message mapper implementation. Now we can just go to the mapping service, copy all of the code, going to the implementation. Let's implement the message mapper, let's implement the method, and let's return the. You can also make it look better by moving each one of those to another line, and that's it. Semicolon at the end. Now right here we will import also the message mapper, and we will use message mapper method reference and to our response. Great. And now we need to return it. Great. So we have our message sent, and now let's create the chat WebSocket handler. So right here in the message new Java class, it will be called chat WebSocket handler. Let's create this class. Let's add the component annotation, the acquire Alex constructor from Lomba, and it will extend the text WebSocket. So extend text WebSocket handler. So we'll have more function. Now we need the message service, the connection manager, object mapper, the JWT, and the user repository. So we will use the user repository. We also need the message service. So message service. We also need the object mapper. So object mapper. Great. We also need the JWT service. So JWT service, and we also need the connection manager. Great. And now we have all of fields that we need right here. So now let's override the wait after connection list. Great, and we will take the WebSocket session and it will throw its exception. So WebSocket session, and it will throw exception. Now we will put this in a try catch block. So try, we will first of all get the query from it. So we will use the get query method that we will create right here in a second. So first of all, let's create the get query method. So bring, it will be called get query, and we will get the WebSocket session, and we will extract the query from there. First of all, let's create a URI object, and we'll get the URI, and we will return. First of all, if the URL is not null, we will get the query, and the URI get query is not null, we'll get the query. In any other case, we'll get an empty string. Now let's create the other helper method that will extract the parameters. So string, we'll call it extract param, and we will get the query and the param. So string query and string of the parameter. Now let's use a loop. So for string of, let's call it pair, we would use query split with the end right here for the key value split equal, and if length, and also for 2 we will limit it. Now if key value length is and key value equal to param, in that case we will return, so let's return the key value of 1. In the other case we'll return an empty string. So now let's override a few methods for our case. So we will override the after connection establishment, and we will put it in a try catch block. So catch, if we catch any exception, in that case we will close the session's isolation. Now that we are finished with the helper method, let's override this method, and it also throws an exception and a little spacing. Now let's put it in a try catch block. So try, and if there is any error we will catch it. So any exception we will just log it into the console. So yes, now let's extract the query. So string query, and we can get the query from the session. Now we can get the token from the extract parameters, and we will use the query, and we will extract the token parameters. Great. Now we need to find the ID, so UID, room ID, and we will extract it. Now let's get the username. So we will use JWT get username from token. Great. Now let's find the user. So user find by username, or else throw. So else throw the exception. So it will be new illegal argument exception. So illegal argument exception, username not found. User is more suitable. Now let's check if the JWT service, and let's check is valid token with the token and the user. If this is not valid, in that case we will close the session. We will use session close with close status of non-acceptable, and we will return. We will close the same right here, close the session. But if the JWT is valid, we'll go to the connection manager, and we will add a new session with the session user and room ID that we have. So this is the first method. Now to the next one, that will be handle text message. So we call it handle text message, and it will get two arguments. One is the WebSocket session, and the other one is the text message. So text message in it is also throws except. Now for the user, let's find our user. So we will use the connection manager, find user from session, and we will give the session. Now if the user is null, in that case we will close the session with non-acceptable status and return. But if we do pass it, we'll use the chat message. It will be the chat message, and it will be a chat message, and we'll use the object mapper. It will read the value of the message that we got right here, and we'll get a payload, and we will use the chat message class. Now let's check if chat message the type is equal to send, so equal to not joined but send. In that case, we will create a new message. We will call it saved, save it, and message service will use the save. So if this is the case, we will go to message, and we will saved, so we'll use the saved. So we'll create a variable type message, we will call it saved, and we will use the message service. We'll use the save method. Now we need to get the IDs. So from chat message room ID, we will get the user ID from the user, and we will get the content from the chat message, and this is it. And now let's create the response. So chat message response, let's call it response, and let's assign it a new chat message. So new chat message response, and let's set up the argument. We will get the ID from save, we will get the room ID from here, we will get the user ID from here, from the user. We will also get the username, so user get username, and we will get the content, and also we will get the sent and semicolon. And now let's use the broadcast, so connection manager, the broadcast to room, and we will use the chat message room ID and the object mapper for to write a string the response. Great. And this is for this method. Now let's create the after connection close method. It will get a session and the status. It will be fairly short. We will just do this, so connection manager, and we will just remove the session. Very simple. And the handle transparent L. This is our next method. It will get the session and the throwable exception. Use auto completion. Great. And we will remove the session as well. So this is for the chat WebSocket handler. And now let's go to the configuration for the WebSocket. So a new Java class. It will be WebSocket configuration file, capital C, and it will be in the config package. Hit enter. And now let's add the annotation for configuration. So first of all is the configuration and enable WebSocket and require as constructor for it. We will need the chat WebSocket handler right here, and we will use the override. Now we need to implement the WebSocket configure. So implement WebSocket configure. Now we need to override this method in our registry dot add handler, and it will be at /ws for WebSocket. And we will set all origin to us. And this is the symbol for our configuration. Now that we are finished with the configuration, let's create the message controller. So new Java class message controller. Let's click enter, and we will use the request controller. And for the request mapping, it will be /API/rooms/ we need the room ID for here /messages, and of course they require our constructor. And we need one field. That's happened. Now we need one field for the message service, and we will use the get mapping, and we create this method return type of response entity, and it will return a list of message response. Yes, let's import those ones. And we will call it get history, and it will get a few arguments. The first one we have right here, the path variable. So we have path variable IUUID room ID. Now we need the page size, so request param in the parameters, and the default value will be set to 0, and it will be an integer for the page, and we'll set it to 10, or we can also set it to 20 for the size. So let's create the method. So we will return response entity of type OK 200, and in the body we will use the message service get history method. So get history, and now we need a few arguments: the room ID and the pageable object. And we will use the page request, and we will use off method, and we will put page and the size, and also we will sort of. We'll use the sort and by. Use the sort and the by method, and it will be by at field, and we will do it in a descending order. Now we'll cast it into a pageable object. Great. So this is for our controller. Let's not forget right here the semicolon. So this is for our controller. So we finish up with our controller, and now let's create the test. So we'll close it, and we'll go to the test folder Java, and we'll create a new test. And this one will be called chat with socket handler. We want to check the handler that we have created. So chat with socket handler, and this will be the test. Now let's add the extend with, and we'll use mojito extension, and we can remove that, and we will use the display name of just chat with socket handler tests. Great. Now we need to mock a few fields. Now in test we don't actually need to write private every time, so we'll use the mock, and for the field will be the message service. We will inject the mock to the chat, and let's add a few more mocks that we need to handle. First one will be the connection manager, so mock for the connection manager. The next one will be mock for the object mapper, so object mapper, and the next one will be mock for the WebSocket session. We can call it just a session. We will also add right here the active profiles to test, because we want to use in-memory database. And now we need a few internal fields. The first one will be for the test users, so it will be user type and it will be called test user. Now the second one will be for the room, so room, and will be test room. And we also need the ID for each and one of those, because we use IUU ID and we cannot just like guess it, so it will be IUU ID, room ID, and the same will be for the user ID, so user ID. Now let's use the before is for the setup. Now let's set up the user, and we will use the builder, so user dot builder. So username will be username, email will be email and mail com, password will be password 13. Let's also add the password encoder so we can create it. So let's authorize it, and let's use password encoder encode for password 1 2 1 2 3, and let's finally build it. Great. Now this user, we will use the repository to save it, so we need also the user repository and also the room repository. So room repository, now we will use the user repository.save, and we will save. Great. Now we can get the user ID from here, and we can do the same for the room. So test room, and let's sign it into room, and let's use the builder right here. First of all, for the name, let's use name. For the description, we will use the description, not that important. For the created by, we will use the user, the test user, so test user. And finally, we could build it. We can set up the members, so members, and we can do just a set up, and we can build it. Great. Now let's save it. So room repository save, and we can get the ID. Great. Now let's create the after each test. So after each test, we want to delete all of the users from the user repository and the room repository if they are still there. Now we will create 4 tests to test the chat WebSocket handler. So let's start with the first test. Let's use the display name, and this will check the handle text message. So let's use test the handle text message method, and we will check if it will save the message and broadcast. So broadcast it to the room, and this is the engine of the display name actually. Now let's create the payload. So string payload, and we will use a triple quote right here. So first of all, we will need and let's start with the type, which will be send. It's one of the type that we have. Then we need the room ID and the content. So room ID, we will use the percentage %s for this, and we just use the content, and it will be a simple hello world will do. Now we use the placeholder, and now we will use the room ID to fill this placeholder. Now we need to create a few mocks, so let's just try to make them as fast as possible. So let's import it, and now we need to create a new chat message. So chat message, and it will be a new chat message. Now we need all of the stuff. First of all, let's start with the chat message type of send with the room ID and the hello world. Great. Now we need to create our mocks. So when the object when mapper.read value from payload and the chat message class, in that case, it will then return this chat message that we have created. We just need to add our test throws exception. Great. Now another mock we need when the connection manager will do this method get username user from session. With the session, we will return the test user, and when the message service will call to this method, to the save method, to save the message with the room ID, user ID, and the content of hello world. In that case, we will return a new message. So let's build it. We will build the message. We'll use the builder. And for the room, let's use the room ID. For the room, we'll use the test room. For the user, we will use the test user, and we build it. Now we also need the ID. So let's create right here UUID for the chat ID. Now let's set it up right here. That ID will be just a random UUID, and let's just use it right here in the ID. So chat ID. Great. And this is for our mock. Now let's create a final mock for this one. Now when the right value is a string, and I don't really care any argument that goes through here, it will return this string that will be with the content. So content will be hello world. Great. So this is for our final mock. Now let's use the chat. The chat WebSocket handler, handle text message, and we will have the session and a new text message with the payload. Now we want to verify, so verify that message service times of 1. It was used the save with the room ID, user ID, and hello world. And we also want to verify, this is a method that we are using in WebSocket testing, verify that the connection manager with times of 1, it was used the broadcast to the room, and it will equal to this room ID and with any argument. So this is our verification right here. Now let's check out what's happening if we don't have a user. So this was the happy path, also the very long path, but the happy path. Now let's create our next test with the display name. We can copy that and we can use it right here. Test method without user, and it should does nothing. So does nothing, and it will throw its exception. Now we don't actually need the payload. Let's create the mock. When the connection manager will get user from the session, it will then return null when we don't have a user. So we use the mock. Let's use the handle text session and new message text with empty payload. Now let's verify that the message service never use this save method with not necessarily those arguments, with any argument, and that this session, so let's verify that this session, let's use the times of 1, was closed. Use the close method. Great. So those are our verification. Now let's test the after connection close and that it will remove the session. So right here, another test, another display name, test the after connection close method, and it should remove the session. Now we don't actually need to create a mock right here. We can just use the, and right here we'll use the chat handler after connection close method with the session and the close status of normal. Close status of normal. Now we want to verify that the connection manager removed this session. Great. So this is our test. Now it was pretty sweet test. Now we'll check out the handle error transport. So another test with the plain name of test the handle transport method, and it should remove the session from the connection manager. So it should remove the session from the connection manager. Great. Now let's create this. Now let's use the handle error transport with the session, and let's add a new runtime exception. So new runtime exception with network error. And now let's verify that it was removed this session. Great. So this is for all of our tests. Now that we implement our code, they all should work. So now let's run the tests, and they all pass. Great. So now let's go and create the test. So now let's go and create the tests for the message controller. So message controller test. Great. Now let's use this Spring Boot test. We will also use the auto configure mock MVC. We will use the profile of test, and we will use the display name, and this will be message controller test. Great. Now we need the mock MVC and the message service. So first of all, auto wired the mock MVC, and we need the Mojito mock bean for, we'll use the mock for the message service. So message service. Now let's write our test. So test, let's use the display name. It will be a get. We have only the get endpoints, so it will be just if you test for it. So get slash API slash rooms slash ID slash messages, and should return 200. Okay, and the list. Great. Now let's use the void, and the name will be get history the access, and it can throws exception, and let's create it. So let's use the message response, and we'll call it message response, and we will create a new message response, and let's add the parameters. So it will be a UUID dot random UID dot random UID and a UID random UID. Now we want to actually save the room ID so we can check it out later. So room ID. Now we need to UID dot random UID. Now we need the room ID. Now we need another random UID, and now the username will be username, and the message will be hello, and finally the time will be local data time now. And great, now let's create our mock. When now we need to import it. Let's close it up. When the message service will call the get history with any argument. It takes 2 arguments, so let's use any and any. It will return a list of, so it will then return list of message response. So now let's use the mock MVC to perform the get operation. So now let's operate the get messages, enter, and we will insert the room ID right there. And let's set up the parameter. So param of page will be 0 and size will be 10 or 20, doesn't really matter. Great, now here we will perform, and then we expect the status to be is okay. Let's import the status. We also expect for the JSON path right in the first items of the array that the content has the value of hello. We'll also expect that the room ID will be equal to this room ID, and finally we'll expect that the username will be the username that we will assign, which is username. So this is our happy path. We also need to run it with a mock user so we don't get any errors. So with mock user, now let's create the not so happy path. So that now without authentication, so display name, we can copy it from here. Place now 401 if 401 when 401 without authentication. So without auth, let's click. Now we just perform, we don't need too much. So let's use the mock MVC. We will perform the get with the random UID, and we will expect that the status to be unauthorized. Now let's create our final test. Alright, so this will be in an empty room. So test display name, and also let's not forget the with mock user. Now with empty room, so it should return an empty list. So first of all, let's create the mock. When it will get the service with any, it will return a list of an empty list. Now let's perform with a random UID, and we'll expect the status to be okay, and the JSON path to be not empty, is empty. And this is for our test. And now let's run them, and now let's run the test. So click here, run. Now let's run, and all of the tests are passing. Our endpoint is complete. Now we need to commit those changes and push them to GitHub. So now let's head over to the terminal. Git add everything, git commit with the message of finish with the WebSocket and point. Click enter. Now let's push it to GitHub. So git push origin to main, and it was successful. Now we need to create our final commit. Now this one will be to create our AWS deploy in the CI/CD pipeline. We need to add another job right here. Let's add this right under here. We'll add the deploy job. Now the name will be deploy and test, and it will run on Ubuntu at Layden. Now for this step, we need to tell them how to deploy. So first of all, usages will be actions slash check out at version 4 at v4. Now another usages will be action setup. So action setup dash java at v4, and it will be with java that version. In this project I use java 17. You can use java 21, or the latest version is 26 at the time of this recording. Now the distribution will be Temurin, and let's commit the final changes. So git add everything git commit dash m finish with the cd pipelines and connect to AWS. Now let's click enter. Now let's push it. So git push origin, and there we have it. So practically we finish our application. We built everything from scratch, and now we have a great application. And this was for today's project, and I will see you in the next one. Real quick, think about every business owner you know, the restaurant, the consultant, the coach, that local business trying to grow online. Most of them have a website. Most of those websites are doing nothing. They look like they were built in 2012. They don't convert, they don't represent the business, and the owner has no idea of how to fix it. That gap, that is literally why you are learning this, because businesses need people who can build things that actually work and actually look the part. Polaris is a studio that serves exactly those businesses. They build, design, and experiences for companies that are serious about their digital presence. No templates, no drag and drop, real work, built from scratch, build to convert. If you know a business owner in that situation, or if you are building something yourself, send them to the Polaris.studio website. It's the kind of work that reminds you what's possible when design is taken seriously. Link below. So, alright, let's go back into the course. So, we finished this course. It was a pleasure for me to help you along this journey. If you have anything that you think can be used of improvements, I would love to hear it down in the comments. I also love you to tell friends and family about this course and local businesses that you know that really try to grow big and become better in today's online present and needs a fresh brand new website that help establish their brand. I would love you to tell them about the Polaris Studio. And this is for today's course, and I will see you in the next one.